Electrical metallic tubing, often referred to as EMT, sees frequent application in water filtration plants, owing to its attributes of cost-effectiveness and durability. Nonetheless, several crucial aspects warrant consideration when deploying the EMT in such environment. The primary concern centers on corrosion. EMT exhibits vulnerability to corrosion, notably in settings characterized by elevated moisture levels or the presence of chlorine. To effectively shield EMT from corrosion, the utilization of zinc-coated or galvanized EMT is strongly advised. The ventilation within the building plays a pivotal role. Adequate ventilation is imperative to forestall the accumulation of chlorine gas, which can accelerate corrosion processes. Conduit fill constitutes another factor of importance. Overfilling the conduit with wires can impede airflow and consequently heighten the susceptibility to corrosion. If uncertainties arise regarding the appropriateness of EMT for a specific application, seeking counsel from a qualified electrician or engineer is prudent. These professionals can furnish expert guidance on ascertaining the suitability of EMT for the intended purpose and proffer recommendations on proper installation and maintenance protocols. To illustrate the practical application of EMT in water filtration plants, several real-world examples are available. In a water filtration plant located in California, EMT served as the raceway system for pumps, controls, and ancillary equipment. To mitigate corrosion risks, the EMT underwent coating, and the building's design incorporated ample ventilation to prevent chlorine gas buildup. Similarly, in a water filtration plant situated in Texas, EMT fulfilled the role of raceway for piping and electrical equipment. In this instance, galvanization was employed to safeguard the EMT against corrosion, and meticulous attention was paid to prevent overfilling the conduit with wires. These instances underscore the versatility of EMT in water filtration plants. When contemplating the utilization of EMT in this type of environment, consultation with a certified electrician or engineer is paramount to ensure its suitability for the specific requirements of the project. Electrical metallic tubing, commonly known as EMT, is a widely used raceway solution, especially indoors, due to its ease of installation and relatively low cost. However, when considering its application in specialized environments such as water filtration plants, careful evaluation is necessary. Water filtration plants present unique challenges primarily due to the potential for corrosive atmospheres. The presence of moisture combined with chemicals like chlorine can significantly accelerate the degradation of metallic components, including EMT. Therefore, selecting the appropriate type of EMT and implementing suitable installation practices are crucial for ensuring the longevity and reliability of the electrical system. The National Electrical Code, or NEC, provides guidelines for the installation of electrical systems in various environments. While the NEC does not explicitly define severe corrosive influences, it mandates that equipment be judged suitable for the condition. This places the responsibility on the installer and the authority having jurisdiction, also known as the AHJ, to assess the specific conditions of the environment and determine whether EMT is an acceptable raceway solution. When evaluating the suitability of EMT, several factors must be considered. Firstly, the type of EMT plays a significant role. EMT is typically manufactured from either steel or aluminum. Steel EMT is more susceptible to corrosion than aluminum EMT, especially in the presence of chlorides. However, steel EMT is generally more robust and can withstand greater mechanical stress. If steel EMT is selected, it is essential to choose a product with a high-quality protective coating, such as hot-dip galvanization or zinc coating with a supplemental clear polymer coating. These coatings provide a barrier against corrosion and can significantly extend the lifespan of the EMT. Aluminum EMT offers superior corrosion resistance compared to steel EMT, particularly in environments containing chlorides. Aluminum forms a natural oxide layer that protects the underlying metal from further corrosion. However, aluminum EMT is generally more expensive than steel EMT and may not be suitable for applications requiring high mechanical strength. Secondly, the installation practices employed can significantly impact the corrosion resistance of EMT. Proper support and bonding are essential for preventing moisture accumulation and galvanic corrosion. EMT should be securely supported using appropriate hangers and straps to prevent sagging and movement, which can damage the protective coating and expose the underlying metal to corrosion. Bonding is crucial for creating a low-impedance ground fault path and minimizing the risk of electrical shock. All EMT fittings and enclosures must be properly bonded to the grounding system using approved bonding jumpers or connectors. Thirdly, the presence of chlorine or other corrosive chemicals in the environment must be carefully considered. Chlorine is a highly reactive element that can attack many metals, including steel and aluminum. The concentration of chlorine in the air and water, as well as the duration of exposure, will influence the rate of corrosion. If the concentration of chlorine is high or the exposure is prolonged, it may be necessary to consider alternative raceway solutions such as rigid polyvinyl chloride conduit, also known as PVC, or fiberglass conduit. These materials are non-metallic and inherently resistant to corrosion. Fourthly, the ventilation of the water filtration plant is an important factor. Good ventilation can help to reduce the concentration of corrosive gases and vapors in the air, thereby minimizing the risk of corrosion. The building should be designed with adequate ventilation systems to ensure a constant flow of fresh air. In areas where chlorine is injected or stored, local exhaust ventilation may be required to remove corrosive fumes. Fifthly, regular inspection and maintenance are essential for ensuring the long-term reliability of EMT and water filtration plants. The EMT system should be inspected periodically for signs of corrosion, such as rust, pitting, or discoloration. Any damaged or corroded sections of EMT should be replaced promptly. In addition, the protective coating on the EMT should be maintained by applying a suitable corrosion inhibitor or sealant. In summary, while EMT can be used in water filtration plants, careful consideration must be given to the specific environmental conditions in the selection of appropriate materials and installation practices. Consulting with a qualified electrical engineer and adhering to the requirements of the NEC are essential for ensuring a safe and reliable electrical system. Additional considerations when using EMT in water filtration plants involve addressing specific potential hazards. Firstly, stray current corrosion can be a concern in water treatment facilities due to the presence of various electrical equipment and grounding systems. Stray currents can flow through the EMT, causing accelerated corrosion at points where the current enters or exits the conduit. To mitigate stray current corrosion, it is essential to ensure proper grounding and bonding throughout the electrical system. Equipotential bonding, which involves connecting all metallic components to a common ground point, can help to minimize voltage differences and reduce the flow of stray currents. Secondly, condensation can form inside EMT, especially in environments with high humidity or temperature fluctuations. The condensation can promote corrosion and damage conductors. To prevent condensation, it is recommended to seal all EMT fittings and enclosures to prevent moisture from entering the conduit system. Condensation fittings can also be installed at low points in the conduit run to allow accumulated water to drain. Thirdly, the use of dissimilar metals in the EMT system can lead to galvanic corrosion. Galvanic corrosion occurs when two different metals are in contact in the presence of an electrolyte such as water. The more active metal will corrode preferentially, while the less active metal will be protected. To avoid galvanic corrosion, it is essential to use compatible metals for all components of the EMT system. For example, if steel EMT is used, steel fittings and enclosures should also be used. If aluminum EMT is used, aluminum fittings and enclosures should be used. If it is necessary to use dissimilar metals, a dielectric insulator should be installed between the metals to prevent direct contact. Fourthly, the location of the EMT run can influence its susceptibility to corrosion. EMT installed in areas that are directly exposed to splashing or spraying from corrosive chemicals will be more likely to corrode than EMT installed in drier areas. Therefore, it is recommended to route EMT away from potential sources of corrosion. If it is not possible to avoid exposure, the EMT should be protected with a corrosion-resistant coating or shield. Fifthly, the selection of appropriate EMT fittings and connectors is critical for maintaining the integrity of the conduit system. Fittings and connectors must be listed and labeled for the intended use and environment. They should be made of corrosion-resistant materials and designed to provide a watertight seal. Compression fittings are generally preferred over set screw fittings in corrosive environments because they provide a tighter seal and are less likely to loosen over time. Furthermore, specific installation techniques can enhance the corrosion resistance of EMT systems. For example, when cutting EMT, it is important to use a sharp cutting tool and to debur the cut ends to remove any sharp edges that could damage the protective coating. The cut end should then be treated with a corrosion-inhibiting compound to prevent rust from forming. Similarly, when threading EMT, it is important to use a cutting oil that is compatible with the EMT material. The thread should be clean and free of burrs, and the fittings should be tightened to the manufacturer's specifications. Finally, consider the use of supplementary protection measures. In particularly harsh environments, it may be beneficial to supplement the EMT system with additional protection measures, such as applying a corrosion-resistant paint or coating to the exterior of the conduit. This can provide an extra layer of protection against corrosion and extend the lifespan of the EMT. Another option is to install a cathodic protection system, which involves applying a small electrical current to the EMT to counteract the effects of corrosion. Cathodic protection can be particularly effective in mitigating stray current corrosion. In conclusion, the use of EMT in water filtration plants requires careful planning, material selection, and installation practices. By considering the specific environmental conditions, selecting appropriate materials, and implementing proper installation techniques, it is possible to create a durable and reliable EMT system that will provide years of trouble-free service. Remember to consult with qualified professionals and adhere to all applicable codes and standards to ensure a safe and compliant installation. Furthermore, the ongoing maintenance and inspection of the EMT system are crucial for identifying and addressing any potential corrosion issues before they lead to significant problems. Regular inspection should include a visual examination of the EMT for signs of rust, pitting, or discoloration. Any areas of concern should be further investigated to determine the extent of the corrosion and the appropriate course of action. If corrosion is detected, the affected section of EMT should be replaced or repaired as soon as possible. The protective coating on the EMT should also be inspected and maintained regularly. Any areas where the coating has been damaged or worn away should be touched up with a suitable corrosion-inhibiting compound. In addition to visual inspections, electrical testing can be used to assess the integrity of the EMT system. Ground resistance measurements can be taken to verify that the grounding system is functioning properly. Insulation resistance tests can be performed to check for any signs of insulation breakdown or leakage current. These tests can help to identify potential problems before they lead to electrical faults or safety hazards. It is also important to keep accurate records of all inspections, maintenance, and repairs performed on the EMT system. These records can be used to track the performance of the system over time and to identify any recurring problems. The record should include the date of the inspection or maintenance, the findings, and any actions taken. By maintaining a comprehensive record-keeping system, it is possible to proactively manage the EMT system and prevent costly downtime or repairs. In addition to the technical considerations, it is also important to address the human factors that can influence the performance of the EMT system. Training should be provided to all personnel who work on or around the EMT system to ensure that they are aware of the potential hazards and the proper procedures for handling and maintaining the system. The training should cover topics such as corrosion prevention, grounding and bonding, and electrical safety. It is also important to foster a culture of safety and responsibility among all personnel. Employees should be encouraged to report any concerns or problems with the EMT system to their supervisors. A proactive approach to safety can help to prevent accidents and ensure the long-term reliability of the electrical system. In addition to the above considerations, it is also important to stay up to date with the latest industry standards and best practices for EMT installation and maintenance. The NEC is updated every 3 years, and it is essential to be familiar with the latest changes and requirements. Professional organizations, such as the National Electrical Contractors Association, also offer training and resources on EMT installation and maintenance. By staying informed and continuously improving your knowledge and skills, you can ensure that you are providing the highest quality electrical services to your clients. Finally, remember that the selection and installation of EMT is just one aspect of a comprehensive electrical system design. The overall design should take into account all of the relevant factors, such as the electrical load requirements, the environmental conditions, and the safety considerations. A well-designed electrical system will be efficient, reliable, and safe for years to come. In closing, using EMT in water filtration plants is feasible with diligent planning and execution. The key lies in understanding the corrosive environment, selecting appropriate materials, adhering to best installation practices, and implementing a robust maintenance program. Consult with experienced professionals and stay informed about the latest industry standards to ensure the safety and longevity of your electrical installations.